Welcome student to my channel, that is Tutor. Last year I discussed one part, that is non-cyclic photophosphorylation. But today I will discuss cyclic photophosphorylation. Okay? In case of non-cyclic photophosphorylation, I told you there are two systems are involved. First one is PS2 and second one is PS1. Okay, but in case of cyclic photophosphorylation, there only PS1 is involved. So as usual, while the photon rays will be passing to while they will be falling on the accessory pigments, first of all they will be energized and that energy will be passing to the reaction center, that is PS1. Okay, and here the wavelength will be 700 nm. And after energized with the help of the sun rays, that means the photon rays, they will release two electrons, and that electrons will be accepted by PEA, that means primary electron acceptor. Clear? And while they will be releasing the energy, that means electrons, at that time one electron hole will be created in the PS1 system, and that electrons will be passing to the primary electron acceptor, and after that they will be passing to the other electron transport channel. And there are some gradients also, lower gradients also. And what are they? First one is FD, that means ferredoxin. Clear? Second one is PQ, that means plastoquinone. Third one is cytochrome complex, and fourth one is PC, that means plastocyanine. And each step they will release some electrons. And in two phases they will release some energy. And here ADP will be added with inorganic phosphate to form ATP. And what are they? First one is between FD and PQ. There one ATP will be formed, and another one and last one cytochrome and PC, that means plastocyanine. So here the total 2 moles of ATP will be produced. Okay, and after that electrons from PC will be passing to the reaction center PS1 again. So it is known as cyclic photophosphorylation. In case of non-cyclic photophosphorylation, here the electrons will not be coming back again the PS2 system, but here the electrons will be again passing to the PS1 system again. That's why it is known as cyclic photophosphorylation. And here some characteristic features are there. Where? In cyclic photophosphorylation. What? Here no photolysis of water takes place. That means splitting of water will not be happening here. Okay. First one is, I told you that. Second one is, here PS1 system is involved where the wavelength will be 700 nm. This one I told you first. And no photolysis of splitting of water also takes place, and no reduction of NADP happens. Okay, and here at the site of this process is stroma thylakoids. And last one, here in two phase they will produce 2 moles of ATP. Clear? So it is the main features of the cyclic phosphorylation. Now I am just discussing what is the difference between cyclic and non-cyclic photophosphorylation. In case of cyclic photophosphorylation, here only 2 moles of ATP will be produced, and this ATP will be required for the Kelvin cycle as assimilatory power. Okay, but in case of non-cyclic photophosphorylation, here ATP will be produced. Not only that, NADPH2 will be produced, okay, by the oxidation reduction reaction, and one enzyme also will be involved. I told you that. Okay, NADP reductase. Clear? And this ATP which will be produced in cyclic photophosphorylation, and one ATP and NADPH2 which will be produced in non-cyclic photophosphorylation. Okay, these are required for the C3 cycle or fixation or producing glucose in C3 cycle or Kelvin cycle as assimilatory power. Clear? And the site of non-cyclic photophosphorylation is Grana thylakoids. But here the site of cyclic photophosphorylation is Stroma thylakoids. It is the basic difference in between the cyclic and non-cyclic photophosphorylation. And cyclic phosphorylation, I told you, no photolysis of water takes place. But in non-cyclic photophosphorylation, here the photolysis of water is important. Clear? Not only that, in non-cyclic photophosphorylation, their NADPH2 will be produced as oxidation reduction reaction with the help of one enzyme, that is NADP reductase. But here only 2 moles of ATP will be produced. So, non-cyclic photophosphorylation is more important rather than the cyclic photophosphorylations. Clear? So, today I have just discussed the cyclic phosphorylation and the difference between the non-cyclic phosphorylation and cyclic photophosphorylation. Clear? So, tomorrow I will come with an interesting part, that is the Kelvin cycle or C3 cycle.